I loved visiting Scrapyard. So it's like something out of Mad Max. There's like metal everywhere. It's so badass. It's really cool. We launched a couple of products to Scrapyards. One which allows them to buy cars. Right now, if you're a Scrapyard, you want to buy a car, maybe you go to an auction. But the key is how much you pay for that car. Like if your AI is over predicting how much an insurer may lose by overpaying for a repair. If it's under predicting, that could be representative of money that like a repairer might not make. If you feel like you don't know enough to do something, it's actually fine because no one knows enough to really do anything. And I think the best way, like when I started in machine learning, I didn't know anything about machine learning. When I started in product management, I'd never done product management before. Now I'm starting a company. I've never started a company before.
Einstein said something like, if I have an hour to solve a problem, I will spend 55 minutes thinking about how to solve it and then 5 minutes solving it. And yeah, it's something I do more and more.
I don't know if that's too weird, but I love potatoes and I love traveling for potatoes.
That's definitely a weird story, but a great one. Thanks a lot for sharing. This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist and I will be your host. So today our guest is Franziska Kirschner. Franziska did a PhD at Oxford in condensed matter physics and then she joined Tractable. She started as an intern, but climbed the corporate ladder. She became a deep learning researcher, and then a deep learning researcher and product lead, and then she became head of AI and product. For those who don't know Tractable, it's a company which uses AI to help assess and repair cars and homes. And in 2021, it became the world's first computer vision unicorn. So quite an interesting startup, but a couple of months ago, she actually left Tractable to start her own company, Intropy AI, and we're also going to talk about Intropy in this episode. So if you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, so let's start now. Hi, Franziska. How is it going? First thing I want to know is, how did you get into this world of AI and data? How did you get into the field?
Yeah, thanks for having me on the podcast. I'm very excited. I think how I got into AI, it's a bit of a weird one. So I started my life obviously as a physicist. Like when I was a kid, I always wanted to be a physicist. That was my dream, to become a professor. And so obviously I did my undergrad, did my PhD in physics. But actually, as I was getting towards the end of my PhD, like I really, really loved what I was doing. But the thing is, like, especially the sort of field that I was in, it's often not very useful, kind of at least within the time span of my life. So we did a lot of really cool research, but then it will be sort of like 20, 50 years until you can really see that coming out in industry. And I always had this thing hanging over me, like I really want to, I guess, contribute more to society, at least like kind of within kind of the time span of my life. And so I was like, okay, I probably don't want to stay kind of doing deep physics research. And when you're a physics PhD, there are kind of three main paths that I saw people following. One is either you stay as a physicist, either academia or industrial, you become a patent lawyer, or you go into AI. And so I thought I probably don't want to stay a physicist. Patent lawyer, I'm not a big writer. I'm bad at reading, I'm bad at writing. And so AI sounded cool. It was also the best paid out of all the options at the time. I had a few friends who were doing it, so I thought I'll just give this a go and see what happens. And yeah, I started off as an intern in Tractable. It was quite funny when I interviewed there because I didn't know anything about machine learning. Like I watched a few YouTube videos and I'm thinking like, things like gradient descent. It's just optimizing a function. I was like, how hard can it be? And so in all these interviews, I didn't know anything at all. Like I didn't even know what back propagation was, and then I got laughed at quite a bit. But Tractable decided to take a chance on me, which I'm very grateful for.
So before we dive into the AI part of your career, I want to zoom a bit on your PhD and the physics part. Can you maybe dive a bit into the PhD? You mentioned it was quite theoretical, but what did you do? What were the key phases of your PhD? Yeah, what did you learn there?
Yeah, so how I got into my PhD topic. So actually when I was a kid, I learned about Maxwell's equations. So these are a bunch of equations that describe how electricity and magnets should work. And one of the equations says that like if you have a magnet, and you split it in half, normally you get two magnets. And this equation said you can never split a magnet in half so that you get like North Pole here and like South Pole here. You always just get two magnets. And a North or South Pole flying around on its own is called a magnetic monopole. And there'd been a lot of kind of theories and research to say maybe they exist, maybe they don't, a lot of studies. And I don't really know why, but I got really into that. Like even like when I was like a teenager. Um, and so I like the reason I chose my PhD research group is first, like the professor in charge was amazing. I'd worked with him during my undergrad, but also I just had this weird fascination with monopoles. Um, and so kind of a big part of my PhD was I did sort of theoretical work for how might we be able to detect monopoles. So there are different types. There's a lot of caveats, but like yeah, just it's how do you detect monopoles in kind of certain kinds of system. And we wrote this paper where we suggested three different experiments, and they were like, if you do any of these experiments, you will see monopoles, and probably it can't be anything else. But obviously, because it's theoretical physics, most of the experiments were kind of physically impossible at the time, which wasn't really an issue
Hmm.
if you're a theorist. I guess like, if you've seen The Big Bang Theory, you know this. But actually, towards the end of my PhD, there was a group in Cornell that managed to build one of the experiments, and we actually made the first observation of this kind of monopole in these kind of special systems. So it was a kind of cool experiment. So the idea is monopoles can live inside certain kinds of crystals, and they're kind of trapped within the crystal. And people would try to sort of look directly into the crystal and find them, sort of look indirectly. But we thought of this experiment that if you're kind of sitting outside the crystal, and monopoles are moving around inside, their magnetic field is quite unique and it sort of fluctuates in a very unique way. So, like when you're queuing outside a nightclub, right? And you can hear like the bass inside and you
Hmm.
know what song it is just because of the bass. It's like that, but magnets. And so they kind of built this thing where it's like a long crystal and then you wrap a coil of wire around it. And then use the wire basically like standing outside the nightclub to listen to the monopoles inside. It was actually really cool, right? Is because the fluctuations that we saw were in like the kilohertz range. So you could actually plug your headphones into an aux jack that the equipment had. I don't know why it had an aux jack, but you could
Hmm.
plug it in and you could listen to the monopoles,
Okay.
um,
Wow.
which is very good. I mean, it sounded really underwhelming.
Hmm.
Like if there are no monopoles, it's like shh. If there are monopoles, it's like shh. But if you take the Fourier transform, it's different. But that was awesome.
So you built an experiment to detect monopoles basically, and you first it was more theoretical, but then you managed to build this experiment and you proved that there was a monopole by listening to it, or how did you prove that there was actually a monopole inside? And can you maybe also just repeat what's a monopole?
Yeah. So I guess the monopole is kind of a north or south pole of a magnet that
Okay,
flies round
okay,
on its
okay, okay.
and so I did most of like the theoretical computational side of if you do this experiment, this is the signal a monopole would produce.
Okay.
And then the team I worked with in Cornell, they actually built the thing. I'm not very hands-on sort of person. I am terrible at building things. I can't solder to save my life. So I'm very glad that they built that. And so I was sort of like the, I guess, theorist in the room that was like running. They were like, oh, we can't get this exact temperature. What does the simulation look like at this other temperature? And I'm like crunching to my really old MacBook Air, trying to make it work. So that was mainly what I did there.
Okay, cool. So you build the theory, and then it should have been quite interesting to have seen and kind of prove that your paper was actually fully true, right?
Yeah, yeah. It was honestly, it was extremely stressful because it was a very expensive bit of equipment that they had and a lot of money and time they put into doing this experiment. So I was just thinking, I was like, oh God, if they do this experiment right and the monopoles don't exist, like I'm so screwed. That like if there was like a bug in my code, right, where it somehow gave the wrong outcome. So it was actually like quite stressful. And I remember like I was staying in Cornell and like upstate New York has very good pizza. And I remember sort of going back to the hotel every evening and then just eating pizza and worrying the whole time. But yeah, when we managed to make the observation, that was really cool to see that line up with theory.
What did you feel the day you actually made the observation and could listen to a monopole? Like, how did you feel?
I think I was just so tired that I was beyond emotions. I think I was very relieved. That was the main thing. And I think it's rude because one thing is kind of making the data measurement, but after the data measurement, there's a lot of like processing you have to do to the data, a lot of kind of interpretation work. So it's like, okay, we're seeing the signal that kind of looks like the theory, but there are things like there could be background effects that you need to remove. There could be all sorts of things, and then you sort of have this like period of a few months of data analysis where anything could happen. I think it's only I think when we put together the paper, and I think also the moment the paper got accepted in Nature, I was like, okay, I think I believe this now that we've actually done this thing, which yeah, which was really awesome.
And your research got recognized, right? I think you got a few prizes. I'm not an expert in condensed physics, so um, but yeah, right. It got recognized after.
Yeah, so I got a few prizes during my PhD, also during my undergrad. I have to say the prize that I'm most proud of was when I was in Oxford. There was a competition where you have to bake your a cake to represent your PhD, and at that time, so this was sort of before the main monopoles part of my PhD. We were doing a study of a superconductor. So superconductor is just a type of magnet that's really good at repelling things. So when you put two magnets together, they repel. It's like that's cool, but superconductor is really good at this to the point where you can make things levitate. So like maglev trains use superconductor technology to levitate off the tracks. And so I was doing a study on how do you improve superconductors. And there's this one superconductor, it's like a crystal. There are layers of, I think it's iron hydroxide and iron selenide kind of interspliced with each other, and then you put ammonia between the layers, and somehow that makes it perform much better than without the ammonia. And so the cake I made, because so all of these superconductors, they're called exotic superconductors because they have like interesting stuff in them, I guess. So I made like an exotic fruit cake where it was layers of like mango cake and coconut cake in the same pattern as the layers of atoms. And then I put like passion fruit cream in the middle to represent the ammonia. And yeah, in this cake competition, it got the best tasting cake, which I was very proud of. And I think that's still one of my best achievements in my life so far.
Okay, nice. You didn't put a magnet inside the cake, right?
Yeah, no, no, I didn't. No magnets inside the cake. That's I don't think any of them are particularly tasty. Actually, you want to know something quite like actually another like fun physics fact. I know this is kind of off topic. You know when you boil eggs, right? And if you boil the egg for too long, like outside the yolk, you get like a little bit of like this blue layer.
Hmm.
And so what happens when you boil eggs? Basically, there is like in the egg white, it's normally like balled up proteins in water, and then the proteins kind of uncurl and like bond together, and that's what makes the egg go opaque. And sort of during this, like sulfur gas is released, and the sulfur gas goes towards the coldest part of the egg, which is the center. And when it hits the yolk, it reacts with the iron in the yolk, and that creates iron sulfide, which is actually a 4 Kelvin superconductor, and the first superconductor I ever studied. But there are different possible structures for iron sulfide to form as a chemical. So it's unclear whether the one in the eggs also superconducts. But anyway, that's just, just cool physics fact.
Okay, you're an expert in how the egg boils.
Yeah, I love food, as you probably noticed by now. So I'm always looking for parallels there.
So let's zoom a bit more into your AI career now. You were passionate about physics. You did your PhD for something more theoretical. Then you made this experiment to kind of prove your theory, and after that, you decide to go into AI. Can you
Mhm.
explain a bit about your transition? Like at the beginning, I guess you know pretty much nothing about AI. How did you learn about the topic, and how did you get this job at Tractable? Did you study something? Did you try to get into the field, or did you apply and then learn on the spot?
A bit of both. So I watched some YouTube videos. It was a combination of a small amount of YouTube and like a lot of Riz, I think. That sort of got me this internship. So the interview process was quite a few steps. It was actually more steps than my interviews like to get into Oxford. So I remember thinking, I was like, wow, this must be a really like prestigious company for such a rigorous interview process. And so kind of like there were like a few technical rounds which I completely like tanked all of them. And then there was one round where I had to do like a little project for a couple of weeks and then kind of go in and talk about it. So the project I did was I pretty much scrape the internet for data about wine and wine pairings because I'm quite into wine as well. And one thing I'm always really interested in is working out how to like find new interesting wine pairings because you know like when you have duck you always have pinot noir and so like there must be other types of like grape varietals that would go well with duck and so we've kind of like scraped all that internet and looked for correlations between like similar foods similar types of wine to try and sort of, I guess, make more interesting, like off-piste suggestions of interesting, say, like new kinds of grapes, new kinds of wine. And so I did that. And then I think at that point, the guys at Tractable said, okay, Frank can probably pick this up. It's all right. And I remember when I joined, I was working with another guy in the team who was supervising me. He's actually now a co-founder as well. He was absolutely not impressed at all because I didn't know anything. And so, but he spent a lot of time kind of teaching me AI. Because one thing is like there's a lot of I guess theoretical stuff about AI, like the theory of backpropagation, the theory of like how to optimize a model, how to build the right architecture. And that is one part. It's important to have those basics, but the thing that I think was more important was actually understanding the problem and the domain that we're working in. So actually understanding how to repair a car plus a basic amount of ML knowledge was probably the best way to go about it. And that's actually where I saw my physics skills come in most useful is when you're trying to solve a problem in physics, it's all about sort of what are the component steps that describe a behavior that you're trying to understand or behavior you're trying to model? How do you build a model that represents those steps? I always found it like a little bit unsettling with AI. Like when you're doing like a physics model, for example, modeling a monopole, you sort of roughly know the equation that describes its behavior, but in machine learning, you're modeling a system, you have no idea what the equation is. You just throw a ton of parameters and you just see what happens, which I found a difficult transition at first. But I think that whole just sort of understanding those components of the problem, how to architect a solution to reflect those components, reflect the symmetries. That's really important as well. I think that was probably the most relevant skill there from my PhD. Not so much minimizing functions at all. That didn't come in so useful.
Not baking a cake.
Yeah, yeah, no, baking cake helps, especially when you become a manager. Because if you're the manager who brings in cake, then you get a lot more brownie points than if you don't.
So yeah, let's dive a bit into Tractable. Before we talk about your deep learning research, do you want to give a high-level intro of Tractable, what it is, what does the company do, maybe also how it evolved, because I know you've been there for like 5 years, so maybe what you were doing a couple of years ago isn't the same as what they're doing now. So yeah, a brief intro on Tractable.
Yeah, so Tractable uses computer vision across a bunch of different use cases. So very much started with kind of accident disaster recovery. So focused on kind of car accidents, looking to sell things to car insurers. So the idea is if you have a car accident, the AI will help you get your car repaired more quickly and for the best price. Because instead of a lot of subjective human assessments having to happen on the car, both from the insurer, from the repair shop, you just have the one AI assessment that in theory is more consistent, more fair, can be tuned to the right standards. So when I started off in Tractable, I was building a lot of the computer vision algorithms behind that. And then sort of as Tractable grew bigger, so I joined around sort of Series B. And then as we grew bigger towards Series D, which was like the unicorn round, we started to branch out in other verticals as well. So one of them is like property insurance. So if a natural disaster hits, how can people get their house repaired faster? Using kind of like you don't have to wait for a person to come on site. You can take a bunch of photos, and then the AI can remotely assess. And also kind of looking into more automotive use cases. So that was actually my role towards the end was sort of trying to identify, build, launch new products in the automotive space. So we launched something to help scrap recyclers recycle more vehicle parts. We launched something to help people sell their car more transparently to used car dealers. But the theme has always been kind of mostly cars, mostly like things that are damaged. And then also like using that computer vision side of things as well.
Okay, super cool. Quite interesting. Yeah, can we maybe dive so that I understand things a bit better? Dive into one project that you worked on where you were a deep learning researcher. What kind of more specific project is it? What kind of algorithms do you use usually to solve those kind of problems?
Yeah, so I think probably my biggest project when I was still a researcher was kind of so we had AI and we had a product that worked well sort of in Europe. We'd launch it maybe like in America as well with a couple of first customers, but we saw that the Japanese car insurance market was huge. Um, and so we wanted to launch in Japan. So my project was to take all the AI we had, take data from our new Japanese customers, and build AI that worked well in Japan, which was a very interesting problem because the cars look completely different in
Mhm.
Japan. It's not like those big trucks you see in the US or like to me normal sized cars in Europe. It's like small cars, like a lot of like these K cars as well. Um, and so the cars look very different, and also the way that cars are repaired is very different. So, for example, repair shops are generally smaller, so a lot more parts are replaced because it's often if you already have the part to hand, you just take off the old one, put on the new one, which for a lot of the cars in Japan is faster than carrying out a full repair. So we had this very big domain shift from our previous AI models, and so the question was, how can you build a new set of AI models that are accurate enough to be used in Japan, um, while kind of leveraging new data, also maximizing how much you leverage sort of our old data as well. Um, and so kind of part of that is just sort of training ML models, but a big part of that is understanding how cars are repaired in Japan. So we went to Japan, we met with kind of repairers, we met with insurance adjusters, um, and it was quite it was difficult. It was my first time, I think, working sort of for Japanese businesses before. I think there's I guess your product has to be like a very high quality. It's
Mhm.
you have to the product has to be really really performant because some of the people who would be using that product have been doing this job for like 25 years. They're super experienced. So he had like a very high bar for performance. Um, and the language barrier was quite difficult as well. I actually learned Japanese for a year to help me better communicate with sort of the customers and our team in Japan. So it was very difficult. It was a very difficult project, but we managed to get there, and we managed to launch in Japan, which was awesome.
So in the end, what was the product that you launched? Is it something to help detect parts that can be repaired? What were like the input outputs of your model and the kind of algorithms that you used?
Yeah, so the idea was when a car has an accident, normally the car goes to a repair shop. The repairer takes photos, submits an estimate, and that's reviewed by an insurer to make sure everything makes sense. And at the time, that process, it took ages because insurers, they would like, there would be a lot of like faxing, there would be a lot of like paper. It would take time to make a proper assessment of the vehicle. So what our AI did is it took in the images, took in additional information, say about the accident, and then it would kind of output what it thought should happen to repair the car. And so insurer could use that, for example, to negotiate with a repair shop if they think there's a better way to do the repair. Yeah, that saved a lot of time there. And kind of the tech at the core, it was mainly sort of computer vision algorithms. I can't
Mm-hmm.
talk in too much depth about
Mm-hmm.
what exactly we did, but it was a mixture of computer vision and then multimodal, also sort of vision and text. For example, incorporating information about the accident. And what it would output then is kind of that sort of repair estimate.
Okay, so the input would be an image of the car, for example, after the accident, some kind of metadata regarding the accident or regarding the customer, and then the output would be, well, which part should be repaired, and stuff like this for the insurer. Your client or insurance companies would then deal with the person who had the accident. Is that correct?
Yeah, yeah. So it'll tell you which parts are damaged, which one should be repaired, replaced, how long the repair needs to happen for, all those details. And then the idea is, because the AI can do this very quickly, that sort of shortens the time needed for the car to get repaired.
Okay, okay, very cool. And what was the key issue there? Was it a matter of retaking your models and retraining for Japan, or what are the key changes that you needed to make to adapt to the Japanese market?
Yeah, so I think the domain shift was the big one. Both the input shift because the cars look
Hmm.
different, and then the output shift because the repair standards are different. And so Tractable has a massive like database of images of cars and then what was done to
Hmm.
repair them. But they were until we launched in Japan, none of that data was from Japan. So obviously you can train a model based just on the Japanese data we had, but that probably doesn't maximize the I guess possible performance, just because like you only have a much more limited data set there. So the question was, how can we leverage all of these like hundreds of millions of images from like the past, from these other domains, combine it with the relatively smaller volume of Japanese images, and then use that to train a really, really good model. And then sort of, if you can crack that, then that sort of allows you to launch much more easily in any new countries as well. So, for example, after that, we launched in Thailand as well, where again, repair standards are different, vehicles are different. Um, so it's that domain shift problem. I think that was the tricky bit.
Okay, and do you know what was the impact of your project and how many additional insurer did you manage to bring, or how much money it made? If you can disclose this, if that's fine.
I don't think I'm allowed to disclose how much money it made, but I think, yeah, since we launched with our first customer in Japan, I think now we have, I don't think I can give you an exact number, but I think most of the total insurance market in Japan, for car insurance. And then also that's because Japan is the sort of country that is, it's say like it has floods, like it has all sorts of natural disasters pretty much. It has I think there are volcanoes there as well, right? Like yeah, there are a lot of natural disasters there. And so it was also our starting point for launching our product for property insurance as well. A lot of these insurers do kind of multiple types of insurance. So one thing was around kind of, yeah, that enabled us to expand within the country, but it also allowed us to enter this new vertical through the connections that we've made.
Okay, so quite a big impact. Well, thanks to AI, actually, you could
Yeah.
have quite a big impact on society and on your
Mhm.
company as well.
Yeah, yeah, definitely. And I think the impact on society, like for me, it's exciting when, say, we get feedback from a user saying, "Oh, this saved me so much time." Or you get feedback from a policyholder saying, "Oh, wow, I can get my car repaired much more quickly." Like that's the reason why I went into AI from physics, is to have that more immediate impact. So yeah, I always think that's really cool.
Okay, no, great. Very cool project. And so, while you do a few projects on deep learning and then you kind of grow into the company and you become between AI and product, right? AI and product lead, is that's your title on LinkedIn. But How did
Yeah.
you how did you grow in this company, and how did your role evolve from pure AI research to more kind of a AI and product role?
Yeah, I think one thing I really liked about Tractable is Tractable is very good at hiring just sort of smart generalist people. So like smart people who can do a bit of everything. So you have like someone who works in sales can also do some data science, or someone who works in engineering can do machine learning. And so the it's sort of, especially in the earlier days when the team was a lot smaller, everyone kind of had to do a bit of everything, and there was never this vibe of, oh, this isn't my job or anything like
Mhm.
that. And so, kind of already, even from the early days, for example, when we're launching in Japan, I was sort of sat in meetings that normally just say like sales or like engagement managers would be in, and sort of having that direct contact with the customer. And I think through kind of, yeah, my work talking to customers, one thing that I always found really interesting. So, when you are making any sort of system on a computer, be it a machine learning model, be it some other kind of simulation, there's always kind of a logic that follows, and you can generally infer back what your system is doing by following
Mhm.
through those logic steps. Humans, no idea. Human, like, there's the whole thing of emotions, and
Mhm.
especially like because Tractable they sold to these big enterprises, so doing something like closing a deal or making a product valuable is very complex. So, for example, like if you want to sell a product to car insurers, you have your economic buyer, who's probably like a VP or a chief sort of title, who they want to get ROI from the product. Then you have a manager who's in charge of making their team use the product, so they want to keep their team happy, and they want to kind of make sure their team hit their KPIs. And then you got the actual user who doesn't want to have any more pain in their day-to-day workflow, and then also they also want to hit their KPIs. So you have like three different groups of people, three different incentives, and all have different emotions about this. So could have worked, say, with AI vendors in the past and had a bad experience, or like there's so many things that feed into it. It's such a complex system. I always found that really fascinating, and so when I was sort of intractable, and then I was kind of I'd become a team lead, I found myself doing more and more of that product side of things, while still kind of thinking a lot about the tech. And so when Tractable was expanding, and sort of going into new verticals, like the founders, they asked me, they were like, "Oh, do you want to try leading one of these?" And I was like, "Yes, obviously, I want to try this out," because it was also kind of the first time we'd launched into new verticals, and first time we'd actually launched outside of insurance. So it's this whole thing, like we didn't even know if this is possible to do as a company, whether this makes sense to do in any profitable way. So I really like difficult challenges that I like. It's not even known whether it's possible to solve or not. So yeah, I thought I'd just give that a go. And it turns out, yeah, I really like kind of being involved in solving a whole problem, not just from the technical side, but the product side, the user side, the financial side. And that's, I guess, why I'm co-founding something now as well, because I really like that.
So when you were a researcher, you were more focused on the tech, and when you started getting into product, you also had to deal with the human side of things. Did this change your vision about how to build product? Because now you suddenly have to consider humans, customers. Um, did it change the way you thought about AI, or not really?
Yeah, I think it changed a lot. Like if you're a tech person, like you're often like very much in love with the tech, keeping up with the latest tech. Whereas as I moved to the product side, I saw a lot of the time that it's much, if you're, say, building a new product, if you're launching an MVP, it's sort of what's the minimal quickest thing that we can do to get validation that this is a good idea, which generally doesn't involve a lot of very attractive tech.
Mhm.
And so, for example, building prototypes that maybe initially, like as you're training the AI, the prototype doesn't have AI in the background, it's, say, like a static demo. And so I think the skill that I picked up from there was kind of how to think about problems and solve problems independent of my tech preferences, if that makes sense. Which it was a hard thing to let go of. But I think I did it. I did it eventually.
What do you think are the pros and cons of both job, like AI researcher and AI product?
Yeah, I think AI research, at least for me, was a lot less stressful. It was you had a lot more time, say, to like sit, think through a problem properly, think about how can I solve this in a proper way that's maybe scalable for the future. Whereas, especially the kind of product role that I was doing was about building, launching new things quickly. It's very much like there's obviously time to think, but it's not about how do I gather the most information possible to make the most right decision. It's like I have 20% of the information I need to make this call. How do I make the right call? So it's sort of the speed at which you have to think is very, very different. I found between the two. You probably like I'm quite high energy, so I
Hmm.
quite like sort of fast thinking, but it's yeah, there is like stress attached to that, especially being a product person. It's your responsibility to find a way to make the product work one way or another. And so I think, yeah, it's stressful, but clearly I thrive on stress, which is why I'm
Hmm.
co-founding something. So it's yes, it's a very different kind of role.
Yeah, maybe a lot more intuition also. Like you can't really test everything. If you've got an AI model and you build it, you usually have a test set, and obviously it's usually different when you deploy it, but at least you know whether it's gonna work or not. Whereas a product, it might be more difficult because you're launching something completely new, so you don't really have a test set or something you can test before launching, right?
Yeah, but I think actually like having the science background and the AI background, it gives you a much better intuition for the technical side of things. So, for example, like you're in a customer meeting and the customer is asking for a certain feature, you can sort of ballpark like, is that something that's possible? How difficult is it? Or say if you're using a product. So we built some quite, I guess, deeply technical products. So we had something which helped people take better imagery of their car. So it had an AI running in your browser, which guides you around taking a video. And sort of understanding how the tech works. Like when you're using the product and something kind of doesn't feel right, you can sort of tie that back to what could be the underlying tech behavior. So being able to actually bridge that between the tech and the product, I found was really useful.
So you think that your AI background, your technical background, made you become a better AI product manager?
Yeah, yeah, I think so. I think there's also some product manager I worked with from similar backgrounds, and kind of if you have that knowledge in the back of your mind, or say if you have a lot of knowledge about the domain, so if you're like a car expert, you have that knowledge in the back of your mind. That I think prepares you to be a much better product manager because you're the one who has the information to make calls quickly, which I think is really good.
So you mentioned that you launched new products toward the end of your time at Tractable. You were launching new verticals. I think it had quite a big impact, like millions in revenue. So do you want to talk about one particular new product that you launched and how it impacted Tractable?
Yeah, so I think probably so it's actually some of the most fun I had in Tractable as well is we launched some products for scrapyards. So when your car reaches the end of its life, often it will go to a scrapyard, which will either dismantle it or leave it in the yard, and people can dismantle it themselves, and then those parts can go and be recycled. And so this is cool because it's good for the environment. Also, I loved visiting the scrapyard. It's like something out Mad Max. There's like metal everywhere. It's so badass. It's really cool. Um, and so kind of we did a couple of we launched a couple of products to scrapyards. One which allows them to buy cars more efficiently. So right now, if you're a scrapyard, you want to buy a car, maybe you go to an auction. But the key is how much you pay for that car depends on how much you think you can sell from it. So how many parts you can recycle. And if like humans can make the decision, but they're going through many, many cars. So it's easy for someone to make mistakes along the way. So the idea is if the AI is seeing all of those cars from auctions, hopefully that will help the human become more accurate too. So the images go in, we let them know what parts could and could not be recycled. And so that means for every car they buy, they're actually recycling more parts on average, which is very cool. So that's one of the products we launched. We also then moved to actually helping people check the cars in at the yard as well, to make sure kind of you have a good idea of what parts are good, bad, helps the dismantling process, helps things like if the car's just coming in first time you're seeing it, helps the pricing process. Um, and I think what I really liked about kind of working with scrapyards is they make a lot of money. They make a lot of money selling recycled parts. But often there are parts of their businesses that are very technical, but then some parts that are very non-technical as well. So, for example, some guys didn't really read emails, and so a manager would print out the email, bring it to you, and say, "Hey, you should reply to this." Um, and kind of getting some of, I guess, like the most non-technical user groups that I've ever seen on board with using like an AI AR app. Um, it was very challenging, but it was very fun to see, I guess, how much the users' lives and processes can be improved
Mhm.
by adding new tech in there. And I thought that was really awesome and like super rewarding as well.
Yeah, what was your approach to make those people who've never used AI comfortable with the tool? Is it some kind of onboarding, a session where you explain all the terms? Because it's already difficult for tech people to get into AI, but so for non-tech people who've never seen it, might be even more difficult.
Yeah, I think it's so like as I was a physicist, I really love doing popular science. So I love this idea of trying to get more people interested in science, interested in physics. And it turns out that's a very similar problem to getting very non-technical people interested in AI and on board with AI. Because if you're a non-technical user and someone say, "Hey, there's a new AI product," you're going to worry. You're going to think, "Is this going to take my job?
Mhm.
How does it? How do I know I can trust it?" There are a lot of questions that will come up. And kind of, I think number one is getting to know the users really, really well, not just like doing a study of many users, but going, say, to the yard, speaking to the users, listening up like what is their family like, what do they enjoy getting up to on the weekends, like building just like, I don't know, like a normal human relationship, I guess, with people. Then kind of when you have a normal human relationship and you're like, okay, like you're hustling, I'm hustling, I want to build this thing, I want to help you, how can we do this together?
Mhm.
Once you have that like sort of trust, then it becomes really easy to develop things with the users. That's another thing. Like, yeah, just don't build things in a hole and then be like, "Hey guys, use the product." Sort of come with something that half kind of works and say, "Look, I know this is a bit crap. You're the expert here. How can we make this thing better to like make your life as easy as possible?" So, I think yeah, I think one thing is just sort of building regular relationships with
Mhm.
like especially your first individual users. And then secondly, I don't just sort of coming in and being humble, like, look, I don't know everything. I'm still working this out as well. You know some things, I know some things. We can probably figure this out together. I think that approach, it seems to work. So that's what I keep trying to do.
You've launched a few AI products which had a very big impact on Tractable. According to your experience, what are the key steps or things we need to think about when launching a new AI product? Like, what are the boxes we should tick, or what are the things you look into before saying, okay, I'm going to launch this new product?
I think the first thing that you need is a problem that's worth solving. Um, and so, like, I've seen like many like AI companies out there who sort of have a technology, they have like an amazing, some proprietary algorithm or whatever, but no clear place to apply it. And then that ends up kind of being a bit of a struggle because it's hard to find a perfect match between a technology and a problem worth solving. So I always start with the problem. Work out what the problem is. You probably have to start with a bunch of different problems. You have a bunch of different technology options. You work out, you have to do some educated guess
Mhm.
of like, is this problem valuable to customers? Is the market big enough? Is it a good fit with the tech capabilities of the team? You have to do an educated guess of which one optimizes the best out of all those. And then once you have picked a problem, it's about understanding that problem really, really deeply. Like, what are the current processes? What's the sort of human thought process when you make decisions? So, for example, when it comes to repairing a car, what are the steps that a human follows when they're trying to work out how to repair the car? Um, and then once you understand the human side really deeply, then you can start thinking about how does the AI architecture, like how can we craft that in a way that emulates the human thought process? So if you build a big end-to-end thing, like probably it'll work for, especially if you use like GPT now, it'll
Hmm.
probably work fine. But if it makes a mistake, no one knows why. And like you can't explain it and it makes it very hard to improve. So you have to kind of architect your system in a way that kind of resembles how humans think about it. And then if you do that and say your AI makes a mistake, you can quite easily go in and say, okay, this module is acting up. It's because of this training data I gave it. And then you can improve much more quickly. So, next thing is architecting the AI. I think when you're like architecting, when you're training an AI, having a test set is very
Hmm.
important. And crafting and understanding what the test set should cover, like what sort of like statistics should the test set have? Is it a random sample over everything you might see? Is it, would you upweight your test set on like certain like weird edge cases that are like very important to get correct? What's the right metric? How do you tie the metric to something like ROI? So, for example, if you want to generate more revenue, what's the right sort of
Hmm.
metric for evaluating your AI model? Or if you're saving time, what's the right metric there? Um, Building that test set, it generally takes a long time, much longer than you think. But if you build it well once, then you're good. Um, and then yeah, once I think you've sort of like you set up a rough architecture, you've got a way of testing it, then you can do the whole AI model training. But
Hmm.
that's like the for me like the least exciting. I like the whole like crafting like the problem space side of things. And then you have to think as well on the side about like how do you get feedback on your model? Not just like, oh, I've trained a model, we've launched it, now we get feedback. But as you're building and iterating on the model, how do you get feedback from your customers? Because also, if your customers are kind of part of that building process, they're a lot more invested in the
Hmm.
success because they feel like it's something that they've helped craft as well. Um, so how do you get that ongoing feedback? And then, yeah, finally, when you launch it, one thing is getting a handful of people on board with the product. The other thing is, say, scaling it across an organization. How do you scale that in a way that doesn't mean you have to go to every single scrapyard in America? Um, so that's at least like for me, like the big. I probably missed something really important now because I just made that up off the top of my head. But I think those are the main steps for me.
So one interesting thing, I mean, the test sets part of things is super important, and I definitely agree with you. Like getting the test set right is one of the most important parts of an ML project because you can train a super big model, have great metrics. If your test set doesn't represent the reality, then the entire project is completely wrong. Like, for example, in your case,
Mhm.
if your test set was um, when you launch your product in Japan, if your test set was only European cars, maybe your model would be doing great in Europe, but it wouldn't work in Japan and your entire product would be really bad. So really thinking about the test sets is super, super important. Like this train test split part, many people just do sklearn, train test split and don't think about it, but it's actually super important to think about this part.
Mhm. Yeah. Yeah, I agree. And I think when you make a test set, the most important thing is humans will interact with your AI output. And then the question is, how will the human interact? Will it look at individual AI decisions? Will it look at like a group of AI decisions? So, for example, an entire repair estimate for a car has maybe hundreds of different AI decisions in there. And you sort of have to tailor your evaluation of the model to mirror the evaluation that the human would do. So, for example, you have a complex AI system to evaluate a repair estimate. Do you sort of look at the performance of the system as a whole, or do you look at the performance of the individual components? And there's also, I guess, different kinds of mistake. So there are mistakes where it's like, oh, AI messed it up, but like it's a bit of a gray area, so it doesn't matter. And then there's the sorts of mistakes where, like, if say someone uploads a picture of a dog and we're like, oh, we have to replace the front door, then people are really going to lose trust. So like these sort of severe errors. Um, And you also got to work to, I guess, try and identify those types of errors. And also, how do you evaluate that in a scalable way without a human having to sort of pick through and be like, ah, this error is okay. Oh, this error is really bad. I think those are, I think, the main things to look out for. And things. So whenever you do a test set, you obviously benchmark your AI against it. But how do you know your AI is as good as a human at doing a task? A lot of the time, AI will be doing tasks that humans do right now, and you don't want to launch something that is like way worse than a human. So then it's like, how do you also measure human performance as well? Humans vary in their decisions. You can't just have one person against a ground truth. You have to like understand the spread of performance of different humans. It can like, yeah, making a proper test set can become a very time intensive thing and can also require effort from your customers as well. So say when we launched in Japan, we wanted our AI to be to Japanese standards, but the specific Japanese standards of our customer. So we said, okay, can you bring some of your experts to label some images for us so that we can check that the AI is sort of performing as well as a human there. So it's making a test set is complicated, and I think as but if like people are listening, they've never done it before. The first time is going to be extremely painful and it's going to take way longer than you think. But once you've been through it once, then it gets easier because you know what to anticipate.
Yeah, and I definitely agree that the benchmark is also quite important because very often you train a model, you get an accuracy or an error
Mm,
of mean absolute percentage error of 20%, and
mhm,
that doesn't mean anything if you cannot compare to a baseline, to a simple model, or to a
mhm,
human. Just getting a single number doesn't mean anything. Your model could be great because the human has an error of 100%, or your model could be really shit because a human has an error of 1%. So comparing to humans or to another simple model, but having a baseline is key to a successful project. Otherwise, you just don't know whether your model is good or not.
yeah, yeah, I agree. I always one of my pet peeves is mean squared error, or root mean squared error. Anything where you're squaring it because that number is very difficult to correlate to any real world variable. So, say you're training a regression model that will predict how much it costs to repair a house, for example. Like very simple example. It's actually way more complicated than that, but like simple example. If you look at something, for example, a mean absolute error, then that gives you an indication, for example, how, like, if your AI is over predicting how much an insurer may lose by overpaying for a repair. If it's under predicting, that could be representative of money that like a repairer might not make. Whereas if you do anything that involves squaring the error, like suddenly you've like lost attachment to all like physical variables. There's probably something that like evolves in a squared way, but at least like what I've seen, money generally doesn't. Money evolves linearly.
Yeah, no, I agree. You can maybe use your model to optimize for this metric, but then when you present or when you look at your models, I mean, personally, I would always look at mean absolute error or mean absolute percentage error to understand the percent error that I've got. But yeah, I don't like root mean square error or mean square error. It just doesn't make sense.
Yeah, yeah, I agree.
So let's close the Tractable chapter. I think we dived quite a lot into it. And I want to move a bit more to the career side of things. Well, first of all, you actually left Tractable a couple of months ago to launch your own startup. So do you want to talk about Intropy AI? Why did you decide to launch a startup? What is Intropy? What are the key challenges that you're encountering now?
Yeah. So I left Tractable in September, I think. So I don't think my LinkedIn's up to date, but like whatever. So I left in September. I traveled for a couple of months, which was awesome. And then, sort of around December time, I founded Intropy with kind of, yeah, my long term collaborator. We worked together in Tractable for 5 years, and he's also my best friend. So, yeah, we decided to start a startup. So, why I felt possessed to start a startup, I think when I was in Tractable, especially like the product role I had, I love this whole thing of having like a completely open space, and you've just got to find something that works, that has a big market, and that matches to the tech that your team can build. And then figure out a way to build an MVP, get market validation, launch it, scale it. Like, I loved that entire process. I loved all of the uncertainty. I loved how fast you could move there. Um, and so like after working on a couple of different products, I wanted to kind of go to the next level of difficulty, which I think is starting your own startup. I think like looking back at the impact side of things, so yeah, the reason I left physics is because I wanted to have more impact on society. I think I was very lucky that I joined Tractable, and that like Tractable was doing like super impactful work. And then I want to see like how can I have even more impact? And I think doing that through starting your own thing, like focusing on problems that like we're very passionate about solving, is probably a good way to go. I don't know. We'll see what happens. And so I guess when I was in Tractable, what I really loved is kind of finding like very non-technical audiences who maybe hadn't worked with AI before, hadn't worked with data before, and improving their lives a lot through AI. So one example is sort of improving kind of people working in scrapyards and their work and their processes by allowing them to check in cars more quickly. So we sort of thought something in that theme was good. One thing I've always found very interesting is there are a lot of companies, for example, in like blue collar spaces that are very non technical, and so we're like, how can we kind of help those companies accelerate even further? Whereas doing something like digital transformation might take a long time. Can you do things faster with AI transformation? And so that's sort of what we're exploring right now is how can we like the dreamers say how could a company in a blue collar space like grow as fast as a SaaS company using the power of AI to make their team's lives easier and make their team perform really really well. Yeah, I'm keeping things a bit vague because we're still exploring. But that's sort of the theme I think that both me and my co-founder are both quite passionate about. And with kind of obviously Gen AI coming up, like a lot of things that were very difficult before. So, for example, understanding unstructured data. For example, like creating materials for non-technical audiences in a scalable way has become a lot easier now. So we're trying to piece together kind of the tech that is making things way more accessible, and then also the problem which we think we might be able to solve.
Okay, so you're still at the beginning trying to understand what the problem really is, developing a few things, and you plan to scale later on. Is that where you're at?
Yeah. I think the most important thing for us is kind of with like first design partners to build something that works really, really well, and is like has some like enough similarities between those first partners that you can see it becoming a scalable product. But I think like whenever you're discovering what to do with a new product, the first iteration is going to be inherently it's going to have unscalable parts because you're learning, you're hacking together things. So I am kind of going in with the expectation that maybe some of the stuff we build will have to throw away, or some of it maybe won't make sense 1 year down the line. But I think the most important thing, like as I said before, is starting with a problem. And if you have a problem and you really understand the problem well, then the kind of solution part will become a lot easier down the line.
Yeah, I think Einstein said something like, if I have an hour to solve a problem, I will spend 55 minutes thinking about how
Yeah.
to solve it, and then 5 minutes solving it. And yeah, it's
Yeah.
something I do more and more, like really blocking hours in my calendar to think about what I'm gonna
Mhm.
code, because then the coding part is easy if you really know what you want to code. It's
Mhm.
super easy, but the difficult thing is knowing what to code. And that's why AI is still kind of, I think AI is still far away of replacing humans. Like for now, they can do our code if we tell them what to do, but they don't really know what they need to do. They still need instructions, and they still need humans to tell them what they need to do. So I think we're
Mhm.
still far away, but let's see. AI progresses so quickly that in a couple of years, this statement might be wrong. But let's see.
Yeah. Yeah. And I think it's quite nice because also, yeah, since starting the startup, there are because we're kind of thinking about totally new domains as well. Like there's a lot of thinking required. So sometimes, like me and my co-founder, we have, I think, quite different ways of solving problems. He likes talking through things and like going through his sort of thought process and like getting feedback on the fly. Whereas I need to sit quietly for about 30 minutes and then I can talk about it. So we're like solving a problem and some like new issue comes up and he'll start talking. I'm like, no, I need to have my quiet time now and then go think about it. So it's yeah, it's been it's really interesting and it's I think like being in a completely new domain. I've been with like working with cars for 5 years now. Working with things that aren't cars, it's very different, and so there's a lot of learning involved. But yeah, I like learning new stuff, so I'm very happy to do that.
Yeah, I'm kind of like you. I also need my quiet time and need to be alone and think about problems alone before I brainstorm. I know lots of people are more, they like to brainstorm together. I can't do that. I need my time alone to really think about it, come prepared, and then brainstorm. But yeah, doing it on the spot is quite difficult. I like to be structured and come prepare and think about the problem alone first. But yeah, I want to talk about the last part of, well, the last part, which is more the career side of things. Two questions on this before we finish the episode. The first one is, well, this show is called AI Stories. So I want you to tell us a story about whatever it can be, a funny story, a mistake you've made, a story about you, something people don't know, but just a story about yourself.
Yeah. Oh god, a new interesting. I should have saved the cake story for this. I think probably one, like I said before, I like learning. I also really like food. So I think maybe one interesting thing about me is I like traveling, but for the purpose of eating potatoes. Like I love potatoes. Like they are some of like okay, like I grew up in the UK, right? The potato game here is fine. But then when I went to Japan for the first time, I tried a potato in Hokkaido. And the potatoes there are relatively smaller. They're quite sweet. They have a much more like gentle texture than many other potatoes. And so, like, I tried this potato. And it like opened my eyes for like how diverse the world of potatoes could be. And sort of since then, I traveled to Hawaii either to try kind of ubi, even though like I guess like it's technically a tuber, but I call them all potatoes here. I traveled to Okinawa to try the beni imo potato. I recently went to Peru to try. Obviously, Peru is the home of the potato. There are over 4,000 native species of potato there, which was just amazing. You go to a market and then you just have like 100 different kinds of potato, all beautiful colors. There are some potatoes that you can eat raw and you freeze them and you eat them like an ice cream. It was quite remarkable. And when I when I was in Peru, I went to the site of the first known domestication of potatoes. So Incan people had these sort of, they kind of look like little theaters, I guess. Like it was basically like circles with like different levels where you could, for example, put different soil mixtures, plant different kinds of seeds to test out what works, what doesn't work for growing potatoes. So this was the first known site where potatoes are planted, and I got really emotionally involved in it. And then I like cried, and it was kind of embarrassing because I was so happy to go to like the birthplace of potatoes. I don't know if that's too weird, but that's I really I love potatoes and I love traveling for potatoes.
That's definitely a weird story, but a great one. Thanks a lot for sharing. Didn't know you could be such a big fan of potatoes.
Yeah, I've managed to find somewhere in England now where you can order like exotic potatoes to grow. So I like growing my own crops on my balcony with varying levels of success. But now I'm going to try. There are potatoes that you can't buy in shops in England, but you can buy like the seeds. So I'm going to see if I can become like an exotic potato grower on my balcony in London.
Yeah, I'm from Brussels and we do some great French fries there. So I don't know if you've tried those, if this comes into the potato family, but yeah, you should definitely try those.
Yeah, no, I love fries, but there is a whole world of potato out there just waiting for you. So if you like potatoes, I can recommend a lot of good places.
So let's finish the episode with one advice. If you just had one advice for people to progress in their career, what would it be? Just one advice.
One advice is if you feel like you don't know enough to do something, it's actually fine because no one knows enough to really do anything. And I think the best way, like when I started in machine learning, I didn't know anything about machine learning. When I started in product management, I never done product management before. Now I'm starting a company. I've never started a company before. I have no idea what I'm doing. I'm just making it up. And having the skill of putting yourself in a completely unfamiliar situation where you just like you don't even know where to start and then being able to work out what to do is, I think, one of the most important skills in itself. So if you feel like you're underqualified for anything, it's fine, don't worry about it. You can just pick it up on the way. It's probably the advice I'd give.
Well, thanks a lot, Franziska. It was great to have you on the show. Have a great day in the UK, and yeah, hope to catch up very soon. Thanks.
Cool. Thanks a lot for having me.
Thank you.